Hello. Today we will be discussing the production and usage of solar energy, energy needs for transportation, and the viability of solar energy as a source of fuel for transportation in comparison to biofuels. Transportation is generally discussed in the context of either passenger transport or freight transport. Passenger transport is categorized into cars and light-duty road vehicles, air, buses, 2 to 3 wheeled vehicles, and rail. And freight transport is categorized into trucks, marine vessels, rail, and pipelines. Light-duty cars took up the most energy consumption, with 44% of the world's total transport energy, followed by freight trucks at 23%. In 2012, worldwide transport energy consumption was measured at 23 quadrillion British thermal units. Transport energy consumption is estimated to increase by 1.4% each year as the population grows and urbanization causes higher demand. At the current rate of increasing energy needs, it is estimated that the energy needs for worldwide transportation will be approximately 94 quadrillion BTU by 2040. Solar energy is produced by nuclear fusion reactions that occur in the sun, primarily through a reaction known as the proton-proton chain. In this series of reactions, multiple violent collisions between atoms occur, causing atoms to fuse together and release massive amounts of energy in the form of both thermal and electromagnetic energy. Solar energy is then collected by technology and stored to be used for other purposes. The two main forms of solar energy technology are photovoltaics and concentrating solar thermal power. Photovoltaics describes the process of converting solar energy directly into electricity using solar panels. Solar panels are made of many solar cells, which contain semiconductors. As light hits those solar panels, those semiconductors absorb that light and electrons are knocked loose from them. Those loose electrons are then directed through wires to create an electric current, and thus sunlight is converted into electrical energy to be used for other purposes. Photovoltaics are currently the most common method of converting and storing solar energy. Unlike photovoltaics, which directly converts solar energy into electricity, concentrated solar thermal power technology converts electromagnetic radiation from the sun into thermal energy. Mirrors known as heliostats are used to concentrate and direct sunlight onto a receiver. This receiver contains a fluid which is then heated by the concentrated sunlight, therefore storing the thermal energy. This thermal energy can then be used to power turbines or be converted into electricity.
To assess the economic viability of solar power and biofuels as alternatives to fossil fuels, consideration of use in private vehicles, public transport, and commercial shipping is required. Chemical potential energy in biofuels is converted into heat energy via combustion. Cars using fossil fuels already use internal combustion engines. The modifications required for a transition to use of biofuels would therefore be minimal, since engine-specific technology is not required for biofuels. It is also possible to integrate small amounts of biofuel into unleaded petrol to create a blend that does not require any engine modifications. Phasing out fossil-fueled cars without threatening the accessibility of private vehicles to the financially disadvantaged masses could therefore be possible. Less accessible to the consumer is the solar-powered electric vehicle. At present, the cost of owning and using an SPEV is far greater than that of biofuel-compatible internal combustion engine vehicles. Currently, the cost difference between the cheapest ICE model and EV model in Australia, as of April 4th, 2022, is $29,000. In comparison to a biofuel ICE vehicle, which only needs seconds to refuel, EVs can take up to several hours to recharge, decreasing the total amount of time that can be spent traveling per day. There is also the factor of the cost of traveling to charging stations, which until EVs become more widely used, will be far less common than regular petrol and gas stations. Similar to blended biofuel gasoline ICE private vehicles, public transportation vehicles such as buses are able to operate using biofuels with minor or no alterations to their engines. Many trains used in today's public transport sector are electric. The more economically practical alternative energy source for trains would therefore to be using solar power. An example of the potential for solar power use for trains are solar canopies. These are stationary solar panel installations above trains. Compared to private EVs, solar-powered electric trains have far more efficiency potential. A 300-watt solar panel on the roof of a small EV could supply approximately 1,600 miles per year, whereas a 300-watt solar panel installed on a solar canopy powering an electric train could supply approximately 4,000 passenger miles per year. Currently, transitioning away from a fossil fuel to a biofuel or solar-powered shipping industry is not economically practical. For biofuels, this is due to price and competition, costing 50 to 150% more than conventional fossil fuels, with insufficient means of production to supply an increased demand. The cost of solar panels presently stands at approximately $360,000 to $711,000 per ship, with returns after about 8 years. Since phasing out fossil fuels from the shipping industry is becoming mandatory, it is likely that ship owners will be forced to settle for these greater costs, causing the actual economic strain to be placed upon consumers, further increasing the cost of living.
In order to make a well-rounded and informed decision about which of these fuels is better for transport, the roles they play in helping or harming our Earth's environment must be considered. Solar power is a form of energy which uses our sun as its generation source. Unlike other, more archaic energy generation methods, solar power is a renewable and significantly more sustainable source of power. Solar panels, the primary medium for harnessing the sun's energy, collect it without producing any pollution, and their comparable energy density to fossil fuels, while admittedly smaller, still makes solar power a feasible replacement for more widely utilized and environmentally hazardous energy production methods, such as fossil fuel combustion. Solar panels and solar power technology exist all over the world, but the production of this technology requires the use of a great deal of water and quality materials, some of which can prove environmentally hazardous if handled incorrectly. Biofuels are also a renewable and sustainable energy source that in many cases boast a similar energy density to such fossil fuels as gasoline. Although this category of fuel does still pollute, its modern accessibility makes it a big competitor in the field of green energy. Additionally, they often boast a relatively simple set of ingredients, with some biofuels being made from food waste. Unfortunately, biofuels are in large overlooked, as a fairly new fuel source, overshadowed by the stigma of new technology. The past 10 years are fraught with consistent survey data to back this up, with biofuels currently supplying less than 1% of global final energy consumption. If the greater public don't know what biofuels are, then any positive effect they may have on our climate runs through a devastating bottleneck. In considering which of these two fuels may better serve humanity's aspirations for a better climate, we can't really disregard one or the other. At present, the infrastructure for wide-scale solar panel implementation isn't available to us, and while the idea of power with zero greenhouse emission may sound nice, a balanced combination of both biofuels and solar power is the more practical option. In order for the fuels we use to be viable substitutes for fossil fuels, they should not only have a better environmental impact, but also be producible in a way that meets energy demands. From a strictly environmental standpoint, solar power is clearly the better option. But from an environmental and practical standpoint, multiple greener energies must be utilized to meet the energy demands of our time. And some emissions are infinitely better than emissions in the ignorance of climate change.